All right, obviously this week our main focus is going to be the water cycle. Your I can statement is I can identify each part of the water cycle, their causes, and the effect that they have on each other. I truly hope that you can do that as we move on. I started this one off like I've done every other Nearpod, and I will need your feedback on this. Even the people that aren't here are welcome to share feedback with me. And this first 2 slides I've done like every other Nearpod I've ever done. I have the term and a picture. Feel pretty confident about that's the sun, right? Then on the next page I have things about the sun that are important. And these are the things that you're going to want to jot down in your notebook. The sun is the catalyst. That means it is what starts the water cycle for us. Okay, again, that's what part of the water cycle is first. It's kind of the chicken or the egg kind of thing. Because if you didn't have precipitation, you couldn't have collection, and you couldn't have evaporation or condensation. We're just going to assume that the water is there, and the sun is going to kick us off. It's going to start us on our journey of the water cycle. Now, it's important, and we're going to really pull in multiple units here. The sun's heat, which is radiation, the movement of heat through electromagnetic waves, heats up the water on the earth. Water is in its liquid form. That's solids, liquids, and gas. And when a liquid gets hot enough, it gains enough heat. It goes through this change that we call evaporation. So the sun is what starts evaporation. It is important to note that. Not all of the water that's in the atmosphere comes from evaporation. There is a second process that the sun is a catalyst for, and this one involves plants. And I know that we refer to it as plants sweating, but that's technically not what plants are doing, although if you can remember it that way, that is fine. What do we call the process when plants lose water through their leaves? Is your hand up? Yes. It would be right here at the bottom, transpiration. So now we look at the sun as not only the catalyst, the starting point of evaporation, the sun is what gets transpiration going as well. All right, so that is the sun. Here's where I need your feedback, and it's not going to hurt my feelings either way. Typically, I've done vocabulary word and picture, and then vocabulary word and definition. I tried something new. Maybe. There we go. I've got vocabulary word, picture, and words all on the same slide. Now, let's take just a moment. So again, as you can see, we've got the vocabulary term, we've got a picture, and we've got the explanation of the vocabulary term all on one page. And it seems like most people like that. I'll get the follow-up on the last class to see. And those of people that are at home that are sick and out, just let me know when you get back. Evaporation is huge. If you look at the word evaporation, we notice, if it'll let me highlight that, it does have that word vapor in the term. So I know that liquid water is turning into water vapor. Evaporation is when water gains enough heat. We're going back to solids, liquids, gas here. It's gaining enough heat so much so that it goes through a physical change from liquid to gas. Water in a puddle, water in a lake, water in a stream, water in the ocean, the largest body of water, all evaporate when they are heated up enough. What happens to water vapor at that point? Will? Water vapor rises. Why does water vapor rise? But it's also what? Not just because it's a gas, it's hot. And heat rises. The water vapor goes up into the atmosphere, and that's getting us ready for that process known as condensation. So evaporation is when the water that is stored on the earth, in lakes, streams, rivers, puddles, the ocean, any of those forms of where water is stored, are heated up enough by the sun that they then turn into a gas and move up into the atmosphere. Evaporation is not the only way that water vapor gets into the atmosphere. I told you that the sun powers two things, evaporation and, correct, Zachary, transpiration. Transpiration. Now, if you look here, you can see either a blade of grass or a leaf here, and it looks like it's sweating, and if you can just remember that much, you are correct. But it rains, and plants take in water. What is the main way plants take in water? How do they get their water? From what part of the plant do they get their water? Allie? They get it from their roots. And that water is transported all throughout the plant body, to the flower, to the leaves, to the branches, to the stems, everywhere in the plant. It needs that water to help it go through the process of photosynthesis. However, much like us, when the sun heats a plant up too much, in order to cool it down, it needs to, quote unquote, sweat. And we call this process transpiration. And I'll highlight this. Transpiration is the process by which plants lose water through their leaves. Transpiration is the process by which plants lose water through their leaves. I was amazed to think about transpiration as I kind of prepared for this unit and really started to think about something in a little bit deeper aspect. Let's look at a rainforest, which is made up mostly of plants, correct? Tons of plants in a rainforest. I remember it was like 300 or something, Wesley, wasn't it, of like orchids. One type of flower, 300 types in the rainforest. I mean, that just is mind-boggling. There is something that does not reach the floor of the rainforest very well. What is that? Oh, Mr. Bullens, you've gone all the way back to the first quarter. Yes, I have. Something doesn't reach the floor of the rainforest very well. What is that? Wesley? Sunlight. And if there's a lake, river, stream, pond at the floor of the rainforest and not a lot of sun is hitting it, guess what not a lot of happens in those lakes, rivers, streams, and ponds? Will? Last slide that we did. The sun causes evaporation. Well, if it can't get that hot because the sun can't hit it, not as much water evaporates. Where do you think most of the water in the areas near a rainforest comes from? Transpiration. And if you read down here, there's small amounts of lakes and streams and ponds, and not a lot of sunlight hits those. Transpiration is a huge factor in getting water back into the atmosphere there. So it's very important to understand. Just after evaporation and transpiration happen, we have condensation happen. So Will told us earlier that the sun heats up water to the point that water vapor rises up into the atmosphere. The sun also is the catalyst for transpiration, which still leads us to having water vapor in the atmosphere. Now, luckily, this isn't where things stop. What would happen if we just kept having evaporation and no rain ever came back down? What would happen? Zachary?
After a long time, we'll be dead.
Everything would dry up. Luckily, something happens in the atmosphere. And when this water vapor gets to a certain point, it starts to cool off and lose heat energy. And it goes back to that chemical and physical changes, or solids, liquids, and gas. And our water vapor goes through a physical change. And it changes from a gas back into a liquid. And we call that condensation. We have also said that condensation in the water cycle is what, class? All right, one more time. Condensation is? Evaporation. Good, you're waking up. The last class was bad about that. We've also seen condensation in other places as well. So we have this water vaporizing, we have this condensation occurring. Water vaporizing, condensation occurring. Is that where it stops? Do the clouds keep collecting water over and over and over again? Is that what happens? No. Eventually the cloud gets full. And when the cloud gets full, what has to happen next? Wilmer. Precipitation. Precipitation occurs. Now, precipitation is any form of water that falls from the sky to the earth. Precipitation. This is how water makes its way back to the earth in the water cycle. And we said it has to make its way back. Otherwise, the things on earth would end up drying up. We have to have precipitation. We know that there are 4 forms of precipitation: rain, sleet, snow, and hail. You need to know those. The biggest thing in here you need to know, though, is precipitation is how water makes its way back to the earth. Now, we know a lot about evaporation. We know a lot about condensation. We know a lot about precipitation. Here's where I'm going to get into something very new. When the water hits the earth, something called runoff happens. And I know that you all giggled and laughed when you watched the little raindrops running across the land in our video on vocabulary today. But this is what happens. Runoff is when precipitation flows across the land's surface. You don't want it just sitting there. That wouldn't be good. You want it to do one of 2 things. You either want it to seep into the ground, which we will get to, or you want it to run off the land and into lakes, rivers, streams, oceans, ponds. You want it to run off. You want the water to flow across the land. And that is what runoff is. Is that the only thing that water does? It rains, there's precipitation. Does it only run down the hill into lakes, rivers, streams, and oceans? Is that the only thing water does? Does some water seep into the ground? Yeah, I mean, last week the ground was still wet because it had rained. Not all of that ran off into places. Some of it seeps into the ground. And there are places that water collects. When water runs off into lakes, ponds, oceans, we say that this water has collected in these places. It also can seep into the ground and collect there. When water seeps into the ground, we call that groundwater. That one's not hard. Water collects in these places, waiting for the cycle to start again. So we know about water collecting in lakes. We know about collecting in rivers and streams and ponds. We even said that's where a lot of water is stored. And typically when I ask you where is a lot of water, you're going to say the ocean, number 1. And then you always follow with lakes, rivers, streams, and ponds. Some of that water collects in groundwater. Groundwater is simply this: precipitation that seeps into the ground and is stored in tiny holes, in pores, in the soil, and in rocks. And you can see in that picture how there's like space in between there. Even something tightly packed as dirt, you can still get water inside of that and put that in there. It's important that you have groundwater. That's where the roots of plants and trees and things go to, for groundwater, where water is stored in the ground.